Hi everyone, Libby and Channing here. As you can see, we are not in our studio, and that is because we are coming to you with a very special invitation to SDSP's second annual AI Plus Expo, taking place June 2nd to the 4th, right here in Washington, D.C. at the Convention Center. It's going to be 3 days full of tech demos, company exhibitions, really important conversations about the future of tech and geopolitics, so you don't want to miss it. So be sure to sign up at expo.sdsp.ai. The event is free and open to the public. And we look straight forward to seeing you there.
Welcome to Strait Forward, a podcast about Taiwan, the island at the center of technological innovation and the global fight for democracy. I'm Channing Lee.
And I'm Libby Lange.
Libby, I am so excited because next week is the Expo.
I know, it's exciting. It feels like we've been waiting months for this.
Yeah, literally. I mean, since last year, right? So for our listeners, yes, we recognize it is a little bit of an off week. Actually, I think the whole month of May has been a little bit off. We just had so much great content that we wanted to share with you. We are releasing this a week before Expo. We want to get really, really pumped and finally answer the question, how did Taiwan's semiconductor industry come to be?
Yeah, I do think that is one of the questions we get the most, right? I mean, how is it that the world's most strategic industry ended up on this tiny island, right? Was it happenstance or was there sort of a larger strategy behind it?
I think now in the news we hear a lot about Taiwan and chips, right? But it almost seems like it just has been a thing forever. Obviously, that's not the case. Obviously, there were intentional decisions behind how that industry developed. And so, we'll get into all of that. But I actually wanted to ask you first, Libby, when you were living in Taiwan, what is kind of the general chip knowledge level, right? If you walk around the street in the U.S. and you ask people about chips or semiconductors, I honestly don't think we'll be able to answer anything. I mean, if I didn't enter this line of work, I might not be able to know, right? So what did the average kind of Taiwanese person or how were your fellow students thinking about the chip industry?
Yeah, I think, when I get asked this question of, did you think about chips a lot when you were living in Taiwan? I guess my answer
your Roman Empire.
Yeah, I guess my answer would kind of be you do and you don't, right? In the sense that I think there's definitely sort of a baseline knowledge that, chips exist and they're important when you're in Taiwan. I knew so many people in college, a lot of my friends who were in the electrical engineering major.
EE.
Yes, which essentially they had joined with the understanding that after college graduation, they would go work at a chip company, have a great salary. It's sort of an aspirational career track for a lot of people, and that's something that they just kind of knew was out there, right? Names like TSMC and UMC are household names in Taiwan. If you're an engineer there, it's very prestigious, right? So I guess on that front, I very much knew that it was a thing. But on the other hand, I think maybe we just didn't talk about it with sort of the same kind of geopolitical lens that we see so much here in DC and really, I guess, in the wider U.S. when we talk about chips today.
Well, chips in itself is a huge topic, right? And it'll probably require several episodes to really dig in. And when we were discussing, okay, how do we want to start introducing the tech element to our podcast, which we definitely should because SCSP does national security and tech. We're thinking, how do we want to talk about chips? Where do we start? We landed on, okay, let's start by talking about how this industry came to be. But also let's start with legacy chips, right? The mature chips. The legacy chips are...
I was going to say, for the uninitiated among us, what is a legacy chip?
Yes, and we'll ask our guest too because I think she is better versed to explain. But I mean, to me, when I think about legacy chips, these are really the chips that are powering all of our electronics, right? Our computers, our phones, our airplanes, not our airplanes, but airplanes, medical devices, military equipment, and cameras, and so just like the most advanced technology, but also just the everyday chips, right? Everything literally has a legacy chip in it.
Mm-hmm. Yeah, I guess, to give an example, I saw that according to some research, a single smartphone uses between 160 and 170 chips, but only 3 of those are considered advanced chips. So all of the rest of those that we need for our everyday life are legacy chips.
Yeah, and I mean, thinking about scaling, right, I think most cars, just the modern day car, now has between 1,000 and 3,000 legacy chips. That's an insane amount of cars. That's why, now that we're thinking about smart cars and electric vehicles, we're really calling them computers on wheels because it's just all of these chips that are used, whether it's GPS, whether it's sensors, to power this electronic device.
Yeah, no, I think that perfectly underscores how much chips are kind of the backbone of our entire modern economy. But I think our listeners will be really interested to hear sort of the humble beginnings of that story. I don't think it's necessarily the story that you will expect to hear when it comes to how this industry came to be. But thinking about where it is now and how important it is and why we really all should care about it beyond the fact that we love our phones and our computers is just really the economic impact of chips themselves, right? So in 2023, the semiconductor industry was worth about $500 billion. By 2024, that number reached $600 billion, and in 2025, it's projected to be somewhere around $700 billion, which puts us well on track to reach $1 trillion in value by 2030.
Yeah, so I mean, we in DC do not speak in hyperbole when we talk about how just ginormous this industry is and how critical it is to our daily lives. And it is very much one of the reasons why people are now paying more attention to Taiwan.
And so to get back to the roots of that story of how the chip industry came to be what it is today, we thought there would be no better guest to bring in than someone from UMC, United Microelectronics Corporation, which was Taiwan's first semiconductor company, established back in 1980. It is still one of Taiwan's largest semiconductor companies. And so today we are so excited to be bringing in Michelle Yoon, who is a corporate communications manager with UMC, to tell us that story.
Yeah, let's get into it. Michelle, it's so great to see you again. Thank you so much for taking the time. Good morning, I guess. It's evening our time, morning our time. Thank you so much for taking the time to talk to us.
Happy to join.
Yeah, I know. When we were thinking about this episode and sort of diving into how Taiwan came to be the chip powerhouse that it is today, we thought there was no better guest to bring on than you at UMC, of course, because of UMC's role as really Taiwan's first semiconductor company, right? It's kind of where it all started when you really think about it.
Yeah, and I mean, we visited you, right, at UMC in February during a trip there, and Michelle did a wonderful job of explaining to us UMC's history, their business, right, and how it contributes to Taiwan's very, very robust chip ecosystem. So we were really impressed, and we wanted to make sure that our audience got a chance to hear directly from you about all that UMC is doing.
So maybe we could start with the story of how UMC came to be. How does Taiwan get its first semiconductor company?
So before I jump into UMC, I want to retrace a bit of history that I think is pretty interesting. So a lot of people attribute the birth of Taiwan's semiconductor industry to a little breakfast shop in Taipei. I'm not sure if you had heard about this. It's no longer around, but it was at this pivotal meeting at this local joint, breakfast joint, that you had the then executive yuan minister, you had several important high profile. They sat in this meeting and then they decided that, all right, semiconductor is the industry we want to pivot to, and we're going to start by licensing this critical semiconductor technology from RCA, which is a US company at that time. So at that time, Taiwan was still very focused on more lower value exports, and they very much wished to pivot to a more higher value added industry. So they chose semiconductor. And because they didn't have that technology on their own, so they decided the fastest way to do it was by licensing this technology. Right? And it was also around that time that ITRI, so 工研院, I think it's in this Industrial Technology Research Institute. It's a government-supported research institute that has funded and incubated many, many important Taiwanese tech companies today. Okay? So it was around that time that ITRI was also founded. So ITRI was actually the entity that was, that was licensing this technology and driving this whole project.
I love that little fun fact that it all started at a breakfast store. I never would have known that.
Very, very Taiwanese, yeah.
Yeah, definitely.
I mean, of course, before this meeting, there was already a lot of activity happening, and then a lot of industrial policy talks. But it was at this meeting that's often attributed as the pivotal moment that started all of the history that includes UMC.
Can I ask, what were the other options, right? If you have, they landed on semiconductors, but what were the other options for, what next industry Taiwan wanted to invest in?
I think that was really much pretty much the way to go. I think the 70s, this is in the 70s, and that was sort of when the idea of digitalization or semiconductors or what it can do, right? So in the 70s, also in the U.S., that was when we were what are those telephones called? The touch tone telephones. So the more digital telephones were becoming more mainstream. Right before it was the dial telephones, and so from that transition, the development in telecommunications, they needed more semiconductors. So I think doesn't happen in a silo in like Taiwan, what Taiwan chooses, but Taiwan reference what's happening in the rest of the world and saw that, identify that as, that should be a crucial technology that we should go for. And I think another important point at the time was that there were a lot of Taiwanese or Taiwanese American or Chinese American that were also already studied in the U.S. And they were involved in this whole development of semiconductors and electronics. And so Taiwan then also had that kind of connection. They were able to ask for advice and saying, hey, do you think this would work in Taiwan if we were to license this technology and then do it here? And then these experts or academics or scholars said, yes, I think it would work. So I think it's also a lot of other factors. It wasn't just the Taiwan sitting here and then thinking, it's like, hey, I want to do that. There's a lot of confluence of factors.
Yeah, no, that's actually it's a really great point. I think one thing I'm hearing from that is that sort of from the get-go, there was a lot of foresight on the part of the government, and also a lot of, I guess, government participation in that decision, right, to focus on semiconductors and make sure that this industry succeeded. But like you said, it's not just, we say we want an industry to succeed and then it does. You have to make certain strategic decisions to actually make that happen. And I was wondering if maybe you could just walk us through a few of the decisions that were made that has turned Taiwan into the tech powerhouse that it is today. What were some of those key decision points?
So I think the founding of eTree, the research institute backed by the government, that was, I think, very key. Because if it wasn't for eTree, then who would be licensing this technology, right? And then the second was the decision to build a science park. So Science Park, which you visited back in February, that's where UMC's headquarters is. That's the first science park in Taiwan. So of course later there was the Tainan Science Park down south, and there's a couple other ones. So UMC, we were the first company to be in the Hsinchu Science Park because we were also the first semiconductor company.
Wow, that's a first.
So I think those two early decisions were really key, and there was direct result of government policy saying, okay, yes, we're going to do this.
And I'm just curious, what is the advantage of being in a science park versus being in an office building in Taipei?
Well, now of course, in Neihu in Taipei,
now it's an office building in Hsinchu.
Science Park. So they talk about the effects of an industrial cluster, right? So I guess you can also think about it, when you go shopping sometimes. You sometimes wonder, why are there so many shops together that are selling the same thing? It's also like a cluster effect. So it's just you pool resources, you share resources, and then so if you start with manufacturing, then you attract your customers, and your customers build close to you, and then you attract your suppliers who establish a branch or a factory near you. Then everything just becomes closer, it becomes more efficient, and you have schools starting up, and then more people going to study relevant majors, and that's your talent pool right there. And so it's just one thing after another. It's sort of like a ripple effect, right? So that is the benefits that we have seen in Taiwan of the cluster effect. And Hsinchu Science Park is the first one, and today it is still one of the biggest and most important.
Yeah, I'm really glad you mentioned the cluster effect, because I think for a lot of people who think about the chip industry, they think, oh, it's just like a fab, just a factory, or you just make it, But the secret sauce that we've learned, right, of Taiwan's semiconductor industry is that cluster effect, right? It's not just that fab and the workers, but it's the whole ecosystem around it that supports it and enables it to grow and continue to expand the way that it has. So. No, absolutely. And, in this whole clustering, with the clustering effect, of course, and with UMC starting out as a chip company, I mean, when UMC was founded, was the kind of destiny to always just become a large, dominant player in the legacy chip space, or what was kind of the original thinking behind UMC's founding?
Okay, so let me go back, retrace a bit, and talk about UMC specifically. So I have to go back to that breakfast meeting.
Yeah.
So that was when the Taiwan government decided, okay, we will go ahead with this project to license technology from RCA. RCA is also no longer around, and so they licensed that technology, and they also sent a group of very bright engineers to RCA, to the U.S. To study how to actually use it. And then when these engineers came back, they set up a demo factory, a demo fab. So we call factories fab for fabrication facility. So they came back to Itri and they built a demo fab. And the yields were surprisingly good. And so they had some confidence in saying, hey, I think this actually will work for Taiwan. And it got to a point where the government, Itri, decided to spin out this demo fab, and that becomes UMC. And that was in 1980. And so, which is why I'm wearing a 45 pin here.
Yeah, congratulations.
Our 45th anniversary this May. So UMC's founding is actually it's very closely tied with the developments in Taiwan's semiconductor industry. So 1980 was where we spun out and officially became the first semiconductor company in Taiwan. And of course, we're not the only one. It was the first demo fab. And after that, of course, there was TSMC also spun out of Itri. So Itri is a very important player. And since then, they've also incubated other companies or efforts that also have been spun out. There is a Taiwan Mass Corporation. So in semiconductor manufacturing, we have to use templates, to kind of print the circuitry on wafers. And so that is what Taiwan Mass Corporation does. And that was also spun up Itri. So that just gives you an idea of how important Itri is in the whole history of semiconductors here in Taiwan.
Quickly, for our listeners who might not be experts on chips, we hear about leading edge chips and then we hear about legacy chips. What's the difference, and what are legacy chips?
So legacy chips usually refer to more mature semiconductor manufacturing technology that has been around for longer. So, I think there's 7 different definitions, but we usually look at it as maybe 14 nanometer and larger. And what does that nanometer size mean, right? It's just the larger the number, the older the technology. So the smaller the number, the more advanced the technology. So today, we're talking about 2 nanometers. And so the nanometer itself refers to the length of the smallest feature in semiconductor manufacturing. But of course, I think today it's becoming more of a marketing lingo. It's becoming harder to define what is actually that length, right? So it's just in general, it's become more of a way to differentiate between different generations of technology. But in general, 14 nanometers or bigger is considered more legacy. But one point I do want to make here is that just because it's old doesn't mean it's old. Right?
Yes.
What I mean by that is that the very bleeding edge stuff, so the 3 nanometer to 2 nanometer, that is very, very high computing power. So you need it for very high computing workloads. So you can imagine a lot of CPUs, GPUs, they need to handle that. But for a lot of other chips that are not the brains of the device per se, they don't need such high computing power, and so it doesn't make sense, from a cost output point of view, to use such expensive, most advanced leading. And so there are so many different applications on the spectrum, right? So say for UMC right now, 22 and 28 nanometer is kind of our sweet spot. We have a lot of business there, and there's a reason for that. And so there's a lot of other applications, for example, like power management, or the radio antenna on your phone that is able to accept and transmit 5G signals and so forth. Those are all very, very important, but they definitely do not need to use such advanced technology. So it's on a spectrum, right? So 28 nanometers is considered very, very advanced for certain types of applications. For some, even like 40 or 55 nanometers considered very advanced. So I would like to think about it as it's kind of it's a spectrum. It's not just black and white, say legacy, mature versus advanced, but it really depends on what is your chip for. Like there's so many different types of chips. Like what is your chip for, and then it has its own spectrum of advanced or mature based on that particular type of chip.
I think it's really interesting that you say that 14 nanometers is already considered legacy chips, because I think the Chips and Science Act from 2022 from the U.S. Congress, I think, defined legacy chips as 28 nanometers or higher. And so, this is evidence that, as the technology evolves, the nanometers just, the number keeps going down. And I just think that's funny, right? In 3 years, 14 nanometers is now considered legacy chips.
Yeah, I think it's bit of a subjective, or it's not a very clear cut line about what is mature, right? Like usually between like 28 and 14, there was a jump in the transistor architecture, so it's a completely different way of building the chip. So I think that's why the line is kind of drawn there. But a lot of people will also consider 14 and 12 and so forth to not be. It's not considered advanced anymore. But maybe it's not considered legacy. It's just kind of in that middle area. Some processors still do use say 14 or 12. Yeah.
Need a new word, middle-aged chips. So you explained, that history of how very brilliant minds, right, in Taiwanese history came together, thought about, okay, what is the next step that we want to take our economy, and obviously they made a very strategic and smart decision, right? Hindsight is 2020, but looking back, we can just think about how really pivotal that moment was, as you mentioned. Can you just describe to us, though, UMC's business model today?
Sure. So UMC is what we call a pure play foundry. So that means that we manufacture chips for our customers. We don't do the IC design. We just take our customers' chip design and then we make it. It sounds easy, but it's actually a very high precision activity. And today we are probably one of the top three, what we call pure play foundries. And of course, TSMC, also in Taiwan, is the biggest. They by far have over 60, close to 70% market share. We are much smaller, but we're the second biggest in Taiwan. And then there are also a few other players in Taiwan that are also what we call pure play foundries. And in the US, there's Global Foundries. They're also only do wafer manufacturing. But it wasn't always this way. So the idea of pure play foundry, you can think about it as a professional division of labor. So back in the probably early 80s, when UMC was founded, all semiconductor companies were what we call integrated device manufacturers, and that simply means they did everything. So your Intels, your Texas Instruments, they would do everything. They would design their own chip, they would make it, and they would cut it up, and they would package it to go into whatever electronic devices they would use back in the day. And that was simply because they had the know-how. They're the ones with the know-how. But as this progressed, TSMC was spun out of ITRI in 1987, and their founder Morris Chang was, he decided that TSMC was going to only do foundry service, right? And so they were the first pure play foundry. And so before then, UMC was still, they were doing chip design and so forth. So of course, TSMC's model became, very successful. And it's successful. We call it democratization of, these services, right? So before, if you were a tiny startup, you had this idea, you want to make this chip. You can't afford to ask Intel or Texas Instruments to make this chip for you. They just would not. They wouldn't. They had no incentive, and it didn't make sense, and then it would probably be very expensive. But once these foundries, such as UMC and TSMC, popped up, then you as a startup, you could go to these companies and say, hey, I want you to make my design. Can you do it? And then we will say, yes, yeah, of course we can do it. So that kind of launched a whole new generation of companies that we call fabless. Mm-hmm. So fabless, not fabulous, but as in they don't have their own plans.
Both fabulous right? and fabulous.
So your NVIDIAs, your Qualcomms, your MediaTek, also from Taiwan, these are fabless companies. And without foundries, they probably wouldn't have gotten to where they are today, because they don't need to spend their resources to buy machines and focus on how to improve yield. They can really focus all their resources and efforts on innovating and creating the most pushing the boundaries of like what chips can look like by focusing on design. So that kind of lays out where UMC is. And so of course UMC in the 90s we decided to follow suit, and then we divested all our other design and other activities, and we only focus on manufacturing, and that's where we are today.
I think one thing that Channing and I were talking about when we were talking about this episode is when I lived in Taiwan, when I was in college, I knew so many people who were going to school specifically with the goal of working at a semiconductor company in the future. There's sort of a clear career path where they could see that from freshman year of college all the way to their career. And so obviously talent is a huge component of this industry. As you just said, chips might sound simple, but are actually really, really hard to make. And I think that the talent piece has really been one of the main challenges we've been facing here in the US as well. And so I was wondering actually how Taiwan has created the ecosystem that it has that is able to continue to innovate on chips, and how UMC is contributing to that, and how other companies like UMC are part of that ecosystem as well.
Fellow students were, they know for sure they wanted to go into semiconductors. And I just want to point out that when you come to Taiwan, and then probably any person you ask on the street, you ask them, hey, it's, for example, it's 14 nanometer and advanced technology node. They can tell you right off the bat. It's just common conversation starter in Taiwan, right? It's like, hey, your stock price of XYZ company, or, did you see this news? Because I think for several reasons, semiconductor is such a huge industry in Taiwan. It props up the stock market. It employs so many people. Semiconductor companies are huge taxpayers. So it would make sense why there is just such a culture of, or such a deep understanding of semiconductors industry in general here in Taiwan. So yeah, I think for that reason, it is, it's quite natural for a lot of young graduates or people who are thinking about what they want to do with their career, that they would choose semiconductors, because it is promising. It's very well paid compared to other jobs in Taiwan. And so if you had any interest in engineering or science, you would probably gravitate towards that industry. And not to mention that it is a global industry, so it gives you opportunities to potentially work overseas in the future. So I think back in the day or even today, it is still a very attractive industry for young people.
So, talking about the global industry, right, we are curious. So from your perspective, obviously this podcast, we talk a lot about geopolitics and kind of how the world is changing, but the private sector has to kind of be a part of that, right? From your vantage point as a business, how does UMC, how do other tech companies in Taiwan navigate just the complexities of all the geopolitical changes that are happening around us? Can you walk us through kind of how companies view all this?
So I think the geopolitical landscape for the semiconductor industry has gotten more complicated in recent years, and I think the turning point was probably COVID, right? Mm-hmm. Like around 2020. Semiconductors really came to the forefront of all policymakers' minds. Right? Before it was just, it's great, it's popping up technological advancement, but it wasn't really on everyone's mind. It wasn't so heavily connected with national security and silicon sovereignty and all those terms that people talk about today. So now I think for a lot of the tech companies, not just in Taiwan, but all over, we benefited from a long period of globalization, of a lot of moving back and forth across borders, because that's basically what has allowed semiconductor industry to flourish, right? Nothing is produced in just one place. So, for example, when we do wafer manufacturing here in Taiwan, we buy our chemicals, say, from Japan, or we buy our equipment from Europe or the US, and then it gets shipped here, and then we make it, and then we might send it to Southeast Asia or somewhere else for packaging and testing, and then it might get sent back here or to China for it to be put into circuit boards, and it gets put somewhere else for assembly, and then eventually, then it gets distributed and system across the world. So the electronic supply chain, and specifically the semiconductor supply chain, is very global. Mm-hmm. So in that context, with a lot of the geopolitical changes, I think it just makes doing business a little bit more complicated. You need to have more risk mitigation systems in place. You need to be a little bit more flexible, more responsive to changes. So for UMC, we're also monitoring, like for supply chain, for example, because we use so many different chemicals and raw materials and ingredients in our manufacturing. We have set up a pretty comprehensive system to kind of monitor, the flow, any disruptions to supply chain. We need to able to early detect it, and then take any corresponding measures to prevent any interruptions in our production.
Yeah, and I know beyond being just very global, I think the semiconductor supply chain is also very competitive, right? There are a lot of different players in the space. We're seeing it feels like we're seeing these major new investments and deals announced, every few weeks in the millions and even billions of dollars. And obviously China is an increasingly major player in the semiconductor space, and particularly legacy chips. They're investing a lot in capabilities there. I'm wondering how you're viewing these developments from your vantage point in Taiwan.
From UNC's point of view, we can look at it this way. Why a customer would choose to work with a foundry is for they look at several things. They look at whether you have the technology to support the chip they want to build, and then they want to look at whether you have the capacity to produce the volume that they need, right? So if you are a small foundry and then you produce one batch for them and you can't support their next generation products, then they'll probably think like, well, there's no continuity. There's no point in investing in this supplier relationship. But if you are able to guarantee your customers saying, I will support you in the long term, right? Not only for this product, but for the next product and next product. And so that's where capacity is important. You need both technology and capacity. But of course, for capacity, it has to make sense, right? You don't just build for the sake of building. Mm-hmm. So for UMC, we are a listed company, and we have shareholders to answer to. So every investment needs to be thought through. It needs to make sense from an investment return point of view. So from that, we do continue to look at expansion opportunities, because that's just we need that to keep growing. But it's not just because everyone else is building, we have to build, right? And so we did recently open our new Singapore fab.
Yeah, congratulations.
We've been in Singapore for 25 years, so the new fab is an expansion of that. And that was something that we decided that makes sense, right? We have customers who are very engaged and saying, yes, we want to have production in Singapore, and as well as support from the government, and it makes sense to build that fab. And in the US, actually, we're collaborating with Intel to develop a new 12 nanometer process that will be manufactured at Intel's fab in Arizona. And from that point of view, we are also expanding our capacity available to customers, but it is not building something from scratch. It is working with Intel to use their existing capacity to provide a new product, a new technology that customers need. So, I think for different companies, it's different situations, right? Like, we can't really comment on what other companies are doing, whether it makes sense for their business strategy. But at least from our point of view, it is we need to be quite cautious and conservative in how we plan our expansion, but expansion is necessary.
I've had the honor of meeting Vice President Bi-khim Hsiao a couple of times in the last, 6 months. And both times she explained to us, obviously, U.S. delegation, visiting, very much in awe, very cool, that we're in this environment. And she would say, Taiwan and U.S. have a very trusted partnership, and that whole trusted partnership idea was something that she had just constantly talked about as being kind of like the cornerstone of why this whole semiconductor industry works, right? Because just like you explained, you have a long-term relationship that the fabs are building with whether it's U.S. Design companies or those around the world. And I think just exactly the way you explained it, that is really what makes this so unique, right? It's that trust among the companies, trust between U.S. companies and Taiwanese companies that really makes all of this work. So it's really cool to hear it from your point of view because you're obviously coming from the company side. For us, we talk on the geopolitical side, but I think it's the same thing, right? What we're talking about here is decades-long trusted partnerships between our two countries, and so I think it's really awesome.
We see a couple trends that will continue to drive semiconductor growth. Semiconductors really is everywhere in our daily lives. We're probably surrounded by, probably just alone in this room, like hundreds of thousands of chips alone. So we will continue to want phones that last longer or in battery life. We want to take better pictures. We want our computers to run better. We want things to be more automated, more smart. And all of those things will need more semiconductors and advancements in semiconductors to move those technologies forward. So, for example, AI is, I would say, still in a pretty early stage right now. It's still building out the infrastructure that's needed. But ultimately, we will see more AI in our daily lives. And that's when AI moves from the cloud to the edge. And I at least for me, I haven't felt it so strongly yet. Maybe I'm just not so up to date on electronic devices. But when that happens, a lot more semiconductor innovation needs to happen. Yeah, because when it gets put into our phones or our watches, it can't be big anymore. It can't be big like data centers. It needs to be small in size. It needs to be energy efficient, but yet it still needs to be fairly moderate performance power, computing power. So yeah, I think we're very excited to continue to contribute to the growth and advancements, whether in technology or just how people live.
Well, thank you so much, Michelle. This has been a fascinating conversation. I think we both learned a lot about chips over the course of this, but we, of course, wanted to turn at the end of this conversation to a bit more of a fun question that we love to ask each of our guests. In the spirit of bringing Taiwan to our audience, we would love if you could just recommend something, and especially you're physically in Taiwan right now, if you could just recommend something from Taiwan that you think might help our listeners get to know Taiwan better.
Well, since I started our conversation with talking about a breakfast shop, I would really recommend that everyone wake up early when you're in Taiwan to go have breakfast. A lot of these breakfast shops open really early, at 5 a.m. and so forth. And controversial opinion, but I think some of the best soup dumplings, xiaolongbao, are actually found at these breakfast shops and not necessarily in the most famous one that everyone goes to, and then for a lot cheaper.
All right, so we will come back to visit you at the Hsinchu Science Park.
Bright and early.
Bright and early, we'll bring you some xiaolongbao from the local breakfast shop. Thank you so much, Michelle, for all these really, really insightful insights into Taiwan's chip industry. I think our audience will gain so much from this. We certainly have, as Libby said. So, I really look forward to seeing you again in the future.
Yeah, thanks for inviting me on the show. It was really fun. Thank you.
Well, Channing, that was an amazing conversation with Michelle. I don't know about you, but I feel a lot smarter coming out of the back of that.
Yeah, I think Michelle explains things so clearly. I mean, partially her job, but also she's just so good at it, which is why I'm so happy that we had the opportunity to bring her to our audience and have her explain just the same way that she did to us when we were in Taiwan, right? Just exactly how Taiwan's legacy chip ecosystem runs.
Yeah, and I think one thing I'll be taking away from this, and I think I'll be thinking about is, she mentioned quite a few times the central role of ITRI, right? And how Taiwan's government really played a role kind of at every step of the way in terms of how Taiwan's chip industry came to be. We talk about this pivotal moment at the breakfast shop, of course, but it wasn't just a moment, right? It was after that. It was the dedicated attention. It was the resources. It was the strategy. And those are all things that are measured not in days and weeks, but often in years. But that is, what it takes when you're building something this complicated.
Yeah, I mean, exactly. It's the public-private partnership model that we at SCSP have been talking about for so long, right? I mean, even in the U.S., for all of our most advanced tech industries, there has always been an element of public sector involvement, perhaps to support, perhaps to provide capital, et cetera. But I mean, similarly, right, it's that relationship between the private and public sector. I totally agree. Mm-hmm. Actually, I was thinking about kind of a caterpillar, sorry, this image just popped into my mind, a caterpillar eating its leaves, wrapping itself into a cocoon, and then one day turning into a butterfly and flying free. And I don't know, that image just popped into my head because I feel like that's kind of what happened with Taiwan's semiconductor industry.
Like you need your cocoon time,
you
right?
Kind of
You
do.
can't just jump from caterpillar to butterfly.
Yeah, I mean, especially for Taiwan's economy. I mean, we've talked about the history, right? And actually, we should do an episode on the economy itself. But Taiwan, again, does not have that long of a history, so it's incredible what they've been able to build in the last few decades.
Yeah, and I know right at the end of the conversation, I think you made a really great point about how relationships factor into that.
Yes, exactly. I think that's going to be my main takeaway from our conversation here today, right? It's the relationships between everything. It's the relationships between the clusters, that clustering effect, right? The companies, physical distance between buildings, the science park ecosystem that they've built up, but it's also the relationship between people. And, whether it's the engineers that maybe meet each other in grad school or even in undergrad, right, and building those relationships, that talent ecosystem that they've been able to build up, all the way up to the people-to-people ties between Taiwan and the U.S. I mean, I think the fact that she mentioned even early on, right, that there were a lot of Taiwanese Americans involved in this process just really speaks to how important kind of relationships are to this whole thing.
Yeah. Well, on the note of meeting people and sparking new ideas, I think there's
tens of thousands of people. Expo.
Yeah, there's really no better endorsement for everyone to sign up for and attend our AI Plus Expo, yes. June 2nd through 4th.
Next week.
Yep, at the convention center here in DC. You definitely won't want to miss the conversations and the demos and really everything that we'll be having there. It's really going to be a great event, and we hope to see you all there.
Yeah, you can see kind of the fruit of chips, of legacy chips, and kind of how technology has evolved since then. All right, I'm getting way too excited. Hope to see you at Expo. And yeah, we look straight forward
to seeing you there.